These are your linear regression notes. They work best with the newer version of the TI-84 calculators. However, the TI-83 Plus and the older version of the TI-84 will still work, but please make a special note when I point out the differences between the two. The first thing that we're going to be doing is looking at data. We'll have you graph it by hand, but we'll also show you how to get the graph on the graphing calculator. In this chapter in particular, we'll be looking at linear data, which means that the shape of the data best correlates with a line. In future chapters and next year in pre-calculus, you might take a look at quadratic and cubic data, but for our purposes, they will be linear. The first type of data that we have here is called a positive correlation. We say that because if we put a line of best fit through the data, which means it goes through as many points as possible, right in the middle, the slope is positive. If you take a look at the second set, there's a line going down or falling. It has a negative slope, so we say there's a negative correlation. In the third example, there really isn't any correlation at all. You could put a rising line through here, you could put a falling line through here, but the data is so scattered that there really isn't a correlation. There's a note down at the bottom. It says positive and negative correlations may be either strong or weak. When the data is very close to the line, we say that that's a strong correlation. Whereas the second example here, the data is a little bit farther away from the line, so we're going to say a weak correlation. In the first example, you'll be doing a little bit more of the work on your own. We will go through the calculator steps, but then in the following two examples after that, we'll make the calculator do most of the work. So for these problems, it says complete the following parts for each problem. Part A, plot the data on the graph and determine the correlation. So we're going to go and plot all of this data that's in the chart. Be careful because we're counting by ones on the x-axis, but the y-axis is scaled by threes. So we're going to plot 1, 1, 3, 5, 4, 7, 6, 11, 7, 12, and 8, 15. And if you look at the data, you can almost put a line directly through all of the points that are there. So it's definitely linear. It says to determine the correlation, the slope of the line, well, the line would be rising, so the slope would be positive. And like I just said, the points would be very close to this line. Almost all of them would touch it. So we're going to say that it's a strong positive correlation. Part B says use your calculator to find the line of best fit. Another name for that is linear regression for the data. So you'll go to your calculator and there's a button up on the top that says Stat. We have a bunch of stats to enter. It says Edit and we want to edit our list. Now your list should be clear if you have a new calculator, but if you're borrowing one, if you have an older one, someone else has used it before you, there may be numbers in here. If you have numbers in these lists, you're going to take your cursor and go up to L1, hit clear. Do not hit the delete button that's up here. Enter. Go over to L2, hit clear, enter. So that you should have clear lists. If you do not have L1 or L2 at the top of your list, please call me over and I will help you get them back. L1 is going to represent all of your X coordinates. So if I go back here, my X coordinates are in the first column. So 1, 3, 4, 6, 7, and 8. I type in the number and I hit enter. And I'm not going to enter the number 10 because I don't have a Y value for it on the other side. I go over to my L2 column and I will enter the Y values, which is our second column, 1, 5, 7, 11, 12, and 15. And before you move on, you want to make sure that these dashed lines at the bottom line up and are across from each other. If they aren't across from each other, you have some data entered incorrectly. Maybe you skipped a number, maybe you accidentally entered the 10 that was there. But if they don't line up, the calculator is going to give you an error later on down the line. So it says to find the best line of best fit, we're going to go to our y equals. And the first thing that we need to do is turn on the plot. So I scroll up to plot 1 and I select enter. If I scroll away from it, there should be a dark box around it now, which means that you've turned the plot on. Now I'd like to go hit graph, but graph won't work if I don't have a good window set up. So I'm going to set up a window that looks like my graph paper here. My x-axis starts at 0 and goes all the way up to, this is technically 11 over here, and we said it counts by ones. So the minimum is 0, the maximum is 11, and our scale is 1. The y-axis starts at 0 and actually goes up to 18. Remember, we're counting by threes. So the minimum is 0, the maximum is 18, and our scale is 3. If I go to the graph now, you should be able to see all of the data. It should look pretty close to what you have on your paper. We just haven't found the line of best fit yet. So in order to get the line of best fit, I'm going to select Stat and tell my calculator that I want to do some calculations. If you see number 4, it says linear regression, which is what this section is about. And it even tells you it's going to be in the form ax plus b, which is very similar to our mx plus b. So you're either going to use your down arrow to go down to number 4, or you can hit the 4 button. And this is where the two calculators differ. If you have the newer version of the TI-84, this is what your screen will look like. If you have the older version of the TI-84, your screen is going to look something like this one. It will say linear regression ax plus b. It won't have the y1 next to it yet. That's what we're about to do. So if you have the older version of the TI-83, what you want to do is make sure your cursor's right next to it and you're ready to enter the y1. If you have the newer version, you need to scroll down next to where it says store regression equation. Now at this point, both of the calculators are the same. Everyone needs to go find the vars button. It's to the left of the clear button. You're going to go over to Y vars, select function, and select Y1. So right now our newer versions of the calculator say store regression equation and there's a Y1 next to it. If you have the older version of the calculator, it should say linear regression ax plus b with a y1 next to it. At this point, you're going to hit enter until it gives you an equation. It's either 3 or 4 times depending on which calculator you have. At this point, everyone's screen should look the same. It tells you the equations in the form y equals ax plus b, which is like our y equals mx plus b. It tells you the a value and it tells you the b value, which you're just going to substitute in. Obviously, we're not going to write out all of these decimals. We'll have you round to 2 decimal places. So our equation is y equals 1.94x minus 0.87. If you did the vars part correctly and you go hit graph, it should put a line through your graph. If you don't have the line, then you're going to have to go back and repeat that whole process using the vars key correctly until you get your line to go through the graph. Part C says use the line of best fit to fill in the missing information. So I'm trying to figure out 10's y value. If I go to my graphing calculator and hit the trace button, which is right next to graph, in the top left-hand corner it should say P1. That means that currently you're tracing your points. If I hit the down arrow, I'm now tracing Y1, which is my equation of the line. I'm going to type in the number 10, and it says x equals 10. 10 was under the x column in our chart. If I hit enter, it should give me a Y value. It says 18.51, that's the prediction. And that's it. There are some common things that happen and students do wrong. Number one, when you get to the test on Friday, it's possible that your plot has been turned off. If you've cleared your calculator, if the batteries die, if someone borrows your calculator, if you're graphing in these equations right here, it might get turned off. So if you don't have any points when you go and hit graph, it could be because that plot is not turned on. The second thing is you could get this error dimension mismatch message. And there's two reasons for this. One, those two lines that I told you need to line up at the bottom of your L1 and L2 columns. If they don't line up, that could be giving you that message. The other reason is that your data may not fit in the window, and we have an example coming up of that one. Third common student error is that you don't get a line to show up in your data, and like I said, that's because you didn't do the vars part correctly. If you have the newer calculator, it needs to say Y1 next to store regression equation. If you have the older calculator, it needs to say Y1 next to store linear, I'm sorry, not store, linear regression AX plus B. And the last thing is that if you go to enter an X value when you're in the tracing mode, there's a couple of things that could happen. One, maybe you didn't press the down key, and so you need to make sure that you're tracing the line and not the points. And the second thing, again, it might be your window. So your window is very important here. So we're going to try this. Problem 2 says the table shows the mean selling price of new privately owned single-family homes for some recent years. Let X equal 0 represent the year 1990. Now this is really important. This is telling you how to scale your X values. So if 1990 is the year 0, 1994 is going to be 4 years later. 1996 is 6 years later. 98 is 8 years later. 10 years, 12 years, and 14 years later. Two things. One, you need to follow the directions and scale it. But two, this creates a smaller window for us, and we're not looking at such big numbers all at once. So part A says make a scatter plot on your graphing calculator and describe the correlation. So we start at stat and edit so that we can enter our data. I'm going to go up to L1, clear, enter to get rid of the old data. Scroll over to L2, clear, enter to get rid of the old data. Our X values are going to be the years and our Y values are going to be the price. So 4, 6, 8, 10, 12, and 14. Are the X values? 154.5, 166.4, 181.9, 207, 228.7, 273.5. And one more time, make sure that those two dashed lines at the bottom are across from each other. If they're not, you will get an error message later on. If I go to my Y equals, I'm going back there to ensure, first of all, that my plot is still on. This is something that you should check every time. Second thing, this equation that's in the Y1 was from the last problem. I need to clear it out. If you have a random line flying through your screen and you don't know what it is, it's because you have old data in there. I'm going to fix the window. I'm going to start at 0 because it doesn't make sense to have negative years. I look at my data and the years go up to 14, so I'm going to go a little bit higher. I'll say 15. And you can scale by whatever you want. I like to scale by 5s. You just need to be able to see tick marks on the x-axis. I'm going to keep the Y minimum at 0 because, again, price isn't going to be negative. The highest one is 273. You could go up to 275. You could go up to 280. If you wanted to go up to 300, you could. Doesn't matter. And I'm going to scale by 25s because I can count from 0 to 275 by 25s pretty quickly. If I hit graph, I should be able to see my data. And I can also see tick marks on each of the X and the Y axis. Looking at the graph now, we can describe the correlation. This is definitely linear. The points are pretty close to a line. The slope is positive. And I would say if we put a line through there, it's a pretty strong positive correlation. Part B says calculate a linear regression. So we're going to go back to stat. We want to do some calculations. Number 4 is our linear regression. Remember, if you have the older version of the calculator, it's going to say linear regression parentheses ax plus b, and you need to get the y1 to be right next to it. If you have the newer version, you need to scroll down next to store regression equation. And regardless of the calculator that you have, everyone will hit vars, go over to yvars, select function, and y1. Now hit enter until it calculates the equation for you. Rounding to 2 decimal places, we're going to write y equals 11.53x plus 98.24. Part C says determine the selling price of a new privately owned single-family home in 2010. Now be careful. Remember, we let x equals 0 represent the year 1990. So 2010 is going to be 20 years after 1990. So I'll go to the graph. If you did the vars part correctly, it should put a line through it. I'm going to hit trace. Remember, I'm tracing the points. I want the down arrow, so I'm tracing the line. And I type in 20. And it's giving me an error message. And I gave you a hint back up here. If you're tracing, there's 2 things. 1, maybe you didn't press the down key, but I just told you to. 2, it might be your window. If I go to my window, the X maximum is 15, and right now you're trying to get it to go up to 20. So I'm either going to change it to 20 or maybe 25. Anything bigger than that is fine. Go back to my graph. I should now be able to hit trace down. Type in 20 for my X value, hit enter, and it predicts 328.81. Now be careful, it does say price in thousands up in our chart. So I'm going to move the decimal place over. $328,810 is our prediction. If I wanted to get even more specific, I actually could go back and take some more decimal places. After the 8, it's 143. Actually, it was 0.29. So I have dollars and cents now. Part D, determine in what year the selling price of a new privately owned single-family home will be $250,000. Now remember, we scaled the Y value so that they were in thousands. So what I actually want to find is $250 because there's thousands. And if I give you a value that's a Y value, you can't hit the trace button. What you're going to have to do is substitute it into your equation. and you're going to have to solve for the x value. So the difference between part C and part D is in part C we gave you an x value, it was a year. In part D we gave you a y value, it was a dollar amount. So I go back to my calculator, to the main screen, sorry. 250, and I'm going to subtract 98.24. I get 151.76. And I'm going to divide that by 11.53. I get 13.16. So the question says, in what year? This is telling me that it's happening in the 13th year. So if it started at 1990 and I go 13 years later, it's going to happen in 2003. Last problem. The table shows the temperature in the ocean at various depths. Part A, make a scatter plot and describe the correlation. So one more time, stat, edit. I need to clear out the old information, so go to L1, clear, enter. L2, clear, enter. I'm going to enter the X values under L1, so 0, 300, 500, 1,000, 2,000, 2,500. If you'd like to scale this one, you can. You don't have to. You could leave it as 2,500. But you could scale it by hundreds, so 3, 5, 10, 20, and 25 if you want to. Smaller numbers are easier to work with. But keep in mind then you have to do some scaling down here as well. If you would like to leave it, you can. And the L2 are your Y values, 22, 20, 13, 7, 6. And I didn't look ahead when I entered the data, and you can see that my two dashed lines are not across from each other. It's because the 25 didn't have any Y values. So I'm going to scroll over to the 25 and just select delete. And now my lines line up. I go to my Y equals, I verify that the plot is turned on, I clear out the old equation that's in there, and I go to window. My smallest X value was 0 and the largest was 25. So I'm going to go from 0 up to maybe 30, count by fives. My Y values, 6 was the smallest. I am going to go down to 0. And I'm going to go up to 25 because 22 was the biggest. And maybe count by fives again. If I hit graph, I have some data here. I can see tick marks down on the bottom and on the left. This data, if I put a line through it, looks like it's going to fall or have a negative slope. And they don't look very close to the line, so I'm going to call it a weak negative correlation. Calculate the linear regression. Stat, over to calc, number 4. If you have the new calculator, cursor should be next to store regression equation. Again, if you have the old calculator, you want it to say linear regression AX plus BY, and your cursor should be next to that. Everyone go to vars, over to yvars, select function, and y1. Then hit enter until it gives you an equation. Y equals negative 0.82x plus 19.85. Determine the temperature in the ocean for a depth of 2,500 meters. Okay, remember we scaled, and depth is our X value. So I'm going to go to my graph. It should have a line going through it. Trace the down arrow because I want to be tracing the line, which should say Y1. Type in 25, hit enter. It says negative 0.72. Since this is a real world problem, we are going to put a degrees Celsius or label it because our chart says the Y values are in Celsius. Part D says determine the depth of the ocean if the temperature is 10 degrees Celsius. Degrees Celsius again is a Y value and you can't do that on your calculator. So we're going to substitute it into the equation and we're going to solve. So 10 subtract 19.85. I get negative 9.85. And I'm going to divide by 0.82. Sorry, negative 0.82. 12.01. So if I go back up here, the depth is in meters. So I'm going to say 12.01 meters. If you are a student who took Algebra 1 last year, your teachers might have shown you some different ways to do these. Specifically, they don't do the the vars part where it stores into Y1 and then draws a line through there. I do believe in part C, they actually have you substitute 25 in for X, but we're going to ask you to use the calculator to find the data because this answer, even though it's rounded, is not as rounded as if I were to substitute this value in. Unfortunately, we're not going to show you today how to substitute Y values in, so we will ask you to do the solving instead.